Hello dear students, in this class I am going to discuss about energy stored in a capacitor. Capacitor, it is nothing but a device which is used to store the electrical energy. Device which is used to store the electrical energy is called capacitor. Capacitor, it is formed by the two conductors separated by a small distance. That distance is filled with an air or vacuum or any other insulator, or it is also called dielectric. In this class I am going to discuss about how that capacitor is charged. Capacitor, it is nothing but device which is used to store the electrical energy. ಈ ಕೆಪಾಸಿಟರ್ ಅಂತಂದ್ರೆ ಏನಿಲ್ಲ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿಯನ್ನು ಸ್ಟೋರ್ ಮಾಡ್ತಕ್ಕಂಥ ಡಿವೈಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಕೆಪಾಸಿಟರ್. ನಾನು ಫಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ಇಟ್ ಈಸ್ ಲೈಕ್ ಅ ಬ್ಯಾಟ್ರಿ, ಚಾರ್ಜಿಂಗ್ ಬ್ಯಾಟ್ರಿ. ನಿಮ್ಮ ಮೊಬೈಲಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಕ್ಕಂಥ ಬ್ಯಾಟ್ರಿನೂ ಕೂಡ ಒಂದು ಕೆಪಾಸಿಟರ್, ನಿಮ್ಮ ವಾಚ್ಗಳಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಕ್ಕಂಥ ಬ್ಯಾಟ್ರಿನೂ ಕೂಡ ಒಂದು ಕೆಪಾಸಿಟರ್. ಅದನ್ನು ನಾವು ಯಾವ ರೀತಿ ಚಾರ್ಜ್ ಮಾಡ್ತೀವಿ ಆ ಕಾನ್ಸೆಪ್ಟನ್ನು ಇಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋಣ. ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ಎ ಕೆಪಾಸಿಟರ್. Energy stored in a capacitor. Okay students, here we consider one capacitor. Initially it is a uncharged capacitor. It is a capacitor. Capacitor means it is the device which is used to store the electrical energy, and it is made up of two conductors separated by a small distance, or two parallel metal plates separated by a small distance. Initially the charge on this capacitor is zero. Just we assume that initially the charge on this capacitor is zero. Energy stored in a capacitor. Now, the battery is connected to this capacitor. The battery is connected to this capacitor. This is a battery symbol. This is the battery symbol and the positive terminal of the battery. This is the positive terminal of the battery and this is negative terminal of the battery. Remember this point students. ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಇರ್ತಕ್ಕಂತಹ ಬ್ಯಾಟರಿಯನ್ನು ನಾವು ಈ ರೀತಿ ಲೈನ್ ಅನ್ನು ಇಲ್ಲಿ ಕೆಪಾಸಿಟರ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥವು ಎರಡೂ ಕೂಡ ಪ್ಯಾರಲ್ ಲೈನ್ಸ್ ಏನಾಗಿರ್ತವೆ, ನಮಗೆ ಈಕ್ವಲ್ ಇರ್ತವೆ. ಬಟ್ ವೆನ್ ವಿ ಡಿನೋಟ್ ದಟ್ ಬ್ಯಾಟರಿ ಹಿಯರ್, ದಿಸ್ ಈಸ್ ದ ಕೆಪಾಸಿಟರ್ ಸಿಂಬಲ್. ದಿಸ್ ಈಸ್ ಕೆಪಾಸಿಟರ್ ಸಿಂಬಲ್ ಅಂಡ್ ದಿಸ್ ಈಸ್ ಬ್ಯಾಟರಿ ಸಿಂಬಲ್. ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಕರೀತೀವಿ, ಬ್ಯಾಟರಿ ಸಿಂಬಲ್. ಅಂಡ್ ದಿಸ್ ಈಸ್ ದ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟರಿ ಅಂಡ್ ದಿಸ್ ಈಸ್ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟರಿ. ಈ ರೀತಿ ಇರ್ತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಆಲ್ರೆಡಿ ನೀವು ಲೋವರ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಕಲಿತಿರ್ತೀವಿ. ಹಿಯರ್ when the uncharged capacitor is connected to the battery, here this is the positive terminal of the capacitor and this is also the negative terminal. Energy stored in a capacitor, it is nothing but transferring the electrons from positive plate to the negative plate. Transferring the electrons from positive plate to the negative plates. Here, when the battery is connected to the uncharged capacitor, here the electrons are pulled from the positive plates. Electrons are pulled from the positive plates and transferred to the negative plate. When an electrons are pulled from the positive plates and transferred to the negative plates, certain amount of work is done by the battery. Here, the work is done by the battery during the process of transfer the electron from this positive plate to the negative plate. Here, the electrons are pulled by the positive plates and transferred to the negative plates. During this process, some amount of charge is stored in this capacitor. Initially, here this is the uncharged capacitor. But when this uncharged capacitor is connected to the battery, connected to the battery. The potential difference across the ends of the conductor. When the potential difference or battery is connected to the capacitor, it pulls the positive charges from the plate. Here this plate. Electrons are pulled from the positive plate and transferred to the negative plate. During this process here, this capacitor is charged. This capacitor is charged. Initially, the charge on this capacitor is 0, and when electrons are pulled from the positive plate and transferred to the negative plate, when it is connected to the battery, here the amount of charge is stored in this capacitor. Certain amount of charge is stored in this capacitor. The small amount of work is done by this battery. Small amount of work is done by this battery. Here the charge presence on this capacitor. Here this is the capacitor C. The charge presence on this capacitor is net. The charge presence on the capacitor is Q is equal to C into V. Charge presence on the capacitor is Q is equal to C into V. Then potential difference means the amount of charge is bringing from one point to another point. Here the amount of charge bringing from one point to another point, that is potential difference. Here Q is equal to C into V, then the potential difference is equal to, that is V is equal to, we know the formula, C is equal to Q divided by V, then Q is equal to, V is equal to Q divided by C. This is equation number 1. Equation number 1, the potential difference. But here, when charge is transferred from battery to the capacitor, certain amount of work is done by the battery. When charge is transferred from battery to the capacitor, certain amount of work is done by the battery. Here, the dq amount of charge is transferred to this capacitor. The dq amount of work is, or dq amount of charge is transferred to this capacitor. Then the work done is small amount of work done. The small amount of work done in transferring the charge dq from the battery to the capacitor is the small amount of work done, dw. dw is the small amount of work is done by the battery to bring the small amount of charge from battery to the capacitor, that is dw. dw is equal to, when that charge bring from one point to another point, that is potential difference V into dq. This is equation number 2. It is a very simple concept. Here Q is equal to C into V. Charge on this capacitor is, Q is equal to, it is the product of capacitance of a capacitor and potential difference. The potential difference is V is equal to Q divided by C. But when certain amount of charge is bring from battery to this potential, here a certain amount of work is done. The small amount of work done, dw, is the small amount of work done to bring the amount of charge dq from this battery to this capacitance, that is the potential difference into small amount of charge dq. Initially the charge on this capacitor is 0. Then dw is equal to V into dq, with the small amount of work is done during the process of small amount of charge is added to the capacitor. Now the total work done by the battery here during the process of charging this capacitor, we know the formula. The total work done, W is equal to integration of dw. W is equal to integration of dw. Where to where we integrate? Initially the charge on the capacitor is 0, it is uncharged. When the charge is supplied to this capacitor, here it pulls the electrons from the positive plates and transfers the electron to the negative plates. During this process it stores the charge. That the final charge is Q. Integrate in between these two limits 0 to Q. Now substitute the dw value in this equation. We get W is equal to integration of 0 to Q. Then dw is equal to V into dq. What is V? V is the potential difference. We know the potential difference formula. V is equal to Q divided by C. Now substitute equation 1 in this equation, or you can consider this is equation number 3. Substitute equation 1 in 3. Substitute equation 1 in 3. We get, that is W is equal to integration of 0 to Q. V is the equation, that is Q divided by C into dq. This is equation number 4. W is equal to integration of 0 to Q. When you are substituting equation 1 in equation 3, we get W is equal to integration of 0. Initially it is uncharged conductor. When we connected the capacitor to the battery, the capacitor gets a charge, that is Q, final charge, Q divided by C into dq. Here C is the capacitance of the capacitor. It is the constant value. When you are integrate any value, take this value outside, that is W is equal to 1 divided by C, and integration of 0 to Q and Q into dq. Q into dq. It is in the form of integration of x to the power of n into dx. You know the simple formula, students. The integration of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1. From using this formula, we can write this equation here. That W is equal to 1 by C. When you are integrating this formula, or when you are integrating this equation, it is in the form of integration of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1. Integration of 0 to Q is equal to Q into dq. Here integration of n plus 1 plus 1 divided by 1 plus 1. Now you get this equation, 1 divided by C is equal to Q square divided by 2 with the initial limit 0 to final limit Q. We get this equation. Now substitute these values. W is equal to 1 by C, Q square divided by 2. Substitute the upper value here, we get Q square divided by 2 minus substitute the 0. Their final answer is W is equal to Q square divided by 2C, or W is equal to 1 divided by 2C into Q square. 1 divided by 2C into Q square. But we know the formula here. Q is equal to C into V. Q is equal to C into V, charge on this capacitor. Now we can write here Q square is equal to CV into whole square. Q equal to CV. Q square is equal to CV into whole square. From using this equation, we can write this. W is equal to 1 divided by 2 into C and CV into whole square. CV into whole square here. C and C get cancelled. We get W is equal to 1 by 2 C into V square. W is equal to 1 by 2 C into V square, which is equal to U. This work done is stored in a capacitor by in the form of electrostatic potential energy. The amount of work done is stored in a capacitor in the form of electrostatic potential energy. Finally, we get the answer. U is equal to 1 by 2 into Cv square, which is the expression for energy stored in a capacitor. Here energy stored in a capacitor, it is in the form of electrostatic potential energy. It is a very simple concept. ನಮ್ಮ ಹತ್ರ ಒಂದು ಕೆಪಾಸಿಟರ್ ಇರುತ್ತೆ. ಆ ಕೆಪಾಸಿಟರ್ ಅನ್ನು ನಾವು ಚಾರ್ಜ್ ಮಾಡಬೇಕು. ಅಗೇನ್ ಮತ್ತೆ ಡಿಸ್ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಅದನ್ನು ನೀವು ಯೂಸ್ ಮಾಡಿದಾಗ ಮತ್ತೆ ಅದನ್ನು ಚಾರ್ಜ್ ಮಾಡ್ತೀರಿ, ಅದು ಮತ್ತೆ ಡಿಸ್ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿರ್ತಕ್ಕಂಥ ಕೆಪಾಸಿಟರು ಅಥವಾ ಅನ್ಚಾರ್ಜ್ ಕೆಪಾಸಿಟರ್ ಅನ್ನು ಚಾರ್ಜ್ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ ಬ್ಯಾಟ್ರಿಯನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬ್ಯಾಟ್ರಿಯನ್ನು ನಿಮ್ಮ ಬ್ಯಾಟ್ರಿಯನ್ನು ನೀವು ಒಂದು ಕೆಪಾಸಿಟರ್ಗೆ ಕನೆಕ್ಟ್ ಕೊಟ್ಟಾಗ ಇಟ್ ಟ್ರಾನ್ಸ್ಫರ್ಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಇಟ್ ಪುಲ್ಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫ್ರಮ್ ಪಾಸಿಟಿವ್ ಪ್ಲೇಟ್ and transfer to the negative plate. During that process, the certain amount of energy is stored in that capacitor. It is an imaginary concept. ನೀವು ಅನ್ಕೋತಿರ್ಬೋದು, ಯಾವುದೇ ಒಂದು ಕೆಪಾಸಿಟರ್ ಅನ್ನು ಚಾರ್ಜ್ ಮಾಡ್ತಿರ್ತೀರಿ, ಯಾವ ರೀತಿ ಚಾರ್ಜ್ ಆಗುತ್ತಾ ಇದು? ಚಾರ್ಜ್ ಆಗತಕ್ಕಂಥ ಪ್ರೊಸೆಸ್ ಇದೆ ಇಲ್ಲಿ. It pulls the electrons from the positive plates and transfer to the electrons to the negative plate. During that process, here the certain amount of charge is stored or energy is stored in this capacitor in the form of electrostatic potential energy. To store this energy, certain amount of work is done by this battery. That work done is equal to electrostatic potential energy. Finally, we get the equation U is equal to 1 divided by 2 into CV square, which is the expression for energy stored in a capacitor. Thank you.